Hello, welcome back to Voltage Synthesizer Basics. I'll be using my dual trace oscilloscope to show you diagram 3 that I have wired up here, and I'll be measuring at point I and point J, and I'll show you that I have twice the voltage at, I think it would be point J, I'm not sure. So I've got channel 1 of the oscilloscope going to point I. That should show 120 volts at point I, and then at point J it'll show twice the voltage, which should be 240 volts, and at point G it measures 0 volts. I don't know how these oscilloscopes work, but that's how they work. And I can't get my oscilloscope to work we had before. What it's showing is peak-to-peak voltages. So for 120 volts, it's actually 240 volts, but it's the peak-to-peak volts is more like 300 volts. If I'm know what I'm talking about here, I'm not sure. But okay, we'll plug this in and I'll show you right away here that this system works. There, now we've got my light bulbs there. Give you a quick view again here of everything. The transformer and the light bulbs. Now I'll just turn on the oscilloscope here and let's see if you can see it when it comes on. There it is. I'm going to have to bring this closer. Oh, I hope you can see that. Okay. But see, there's two waveforms there. The yellow one is channel A, and the blue one is channel B. And you can see the blue one is about twice as much. Oh, there it is. The blue waveform is twice as high as the yellow one. So I hope you can see that there good. Whoops. Had a little something go on there. Okay. That proves that we have twice the voltage. I'll just pause this for a minute and turn it off. Okay, that worked out okay. I just want to show you here, this is the probe that goes to channel A of the scope, and it showed 120 volts, and it's connected to the series connection. Oh, that's what fell off here. The black wire of this bulb going to the white wire of this bulb. That's the series connection between the two light bulbs, of R1 and R2. And channel B of the oscilloscope, this one, is connected to the white wire that goes to this bulb, and then this black wire is joined at I and it goes to H. And down here at G, the black wire of this bulb, it measures 0 volts. So the oscilloscope is just measuring in one direction kind of way. as it goes down. As it goes down. Now, I wanted to talk in an earlier video. I talked about diagram 3, and I didn't go through the portion here with the no-step transformer. If you follow the current path, it doesn't seem to make sense. So what I said I was going to do is I'm going to redraw it, because point D should be joined with B, and C will be joined with J. So I redrew that, and I went through it again, and it poses the same problem as before. So it doesn't really matter which way is hooked up. But I think maybe it could be possible that it's not using as much current, because when it goes down from R1 to R2, it's putting 833 milliamps down there. But when it goes up from R2 to R1, when it changes direction, the alternating current, it might be only putting out 416 milliamps, because that's the way it doesn't make sense here. But electricity is the light and electricity from light bulbs is going so fast that your eyes can't notice it. So that if that's the case, then it would be a good thing, because you wouldn't have to use as much current, because you really don't need that much current, because it's at the speed of light and 60 cycles per second. You don't really need all that, I don't think. So that could be the thing. Okay, enough on that. I want to show you diagram 4. Here's diagram 4. Now, I used the 2-prong plug symbols instead of that alternating current symbol I used before in diagram 3. Now, remember in diagram 1, I had that warning message saying not to wire this up. So that applies here too. So like Selena Gomez sang that song, hers, I keep repeating, repeat. What I want to do is repeat here. I want to keep repeating, do not wire this up, because it will not work, and it's going to cause a short circuit, and you don't want electrical fire or something like that happening. Okay, now why? Why doesn't this work? I actually need a better way to show this. I got too much light here. I can hardly see what I'm doing. Okay, I just have to talk about it here, and maybe if I put it. Okay, plug 1 and plug 3 are just straight through parallel branches. They're not connected to a no-step isolation transformer. Now, let's say there's 2 wires coming out of each plug, eh? Now, let's say the top wire is the hot wire, and the bottom wire is the neutral wire, and for all of them. So now the neutral wire of plug 1 is connected to A of plug 2, and B of plug 2 is connected to the hot wire of plug 3. Now the problem with that is the neutral wire, or should I say the hot wire of plug 3, that's a short circuit right to the neutral of plug 1. So that's why that's not going to work. It's going to, it's going to blow your breaker switch, or should I say trip it. And if it doesn't do that, then you're going to have electrical fire or something shorting out. So that's why you can't do that. Now, oh, I see. Plug 5, I got a center tapped connection there. And if this did work, it would be over 480 volts, and then whatever voltage you use for that bottom transformer. I'll show you that to you in diagram 5, what I'm trying to do here. But do not wire this up because it will not work. But it explains that why you can't do that. Okay, now here's diagram 5, and it's much more complicated. Now, this is a simplified, not a simplified, but a better way of doing this. Now, what I've done is plug 1 and 2 is just like diagram 3. It creates 240 volts, and then you see what that V is. That's a voltmeter, measures 240 volts there. And then what I do from there, I create 2 more parallel branches at C and D and E and F. Then E and F is the primary of the no-step transformer. But then D and L are the series connection there. So what you'd have there is 480 volts across R1, which is just load resistance of all the devices that you hook up. So when you have 480 volts, that enables you to light up 400 watt light bulbs with the current needed for just one. If my theory is correct, and I'm going to prove this in some later videos. Now also the plug 3 is connected to a no-step transformer, but you can see it's center tapped there. And let's say you wanted an odd voltage like 547 volts. How would you get that? Well, first you create the 480 volts first, and then you wire that up in series through the connection M and G. That's a series connection. But that center tap should be an adjustable tap that you can kind of slide up and down, and then you adjust that for 67 volts. Therefore, 480 volts plus 67 volts equals 547 volts. Now, why would you need a voltage like that? Well, I don't know myself really, but it would be very valuable for research in chemistry. For I won't say right now what it should be used for, but electrochemistry and things like that, even atomic research, it would be important for that, to get the proper voltages and the current amounts that you want. Okay, I think that's all I have to say about that. Yes, okay. Okay, I'm going to be doing this sometime in the later video. This uses 3 no-step transformers, but I'll show you diagram 6 and then I'll tell you what I'm going to do next. Okay, here's diagram 6. Now that would just show you how to make 360 volts. And the only drawback to that is that you have to add a no-step transformer every time you add 120 volts. So that's if you only want 360 volts. But then you could always, diagram 5 is the better method because you get 40 volts with just 2 transformers. So it steps it up faster. Okay, now I'm not sure about my next experiment is going to be, I think I've come up with a method where I can just use one transformer, no step isolation transformer, and I can make more parallel branches and I can isolate them from the other straight through parallel branches from just a 3-prong plug or 2-prong plug, don't matter. But you gotta have a ground there. You notice in my oscilloscope I made a ground wire here. Just show you that here. I put a new plug on here, right here, 3-prong. You can see better there. Get this light out of here. And then I put a copper wire coming out of it for the ground, right here. And then you can see I got my ground clips here connected to them for the oscilloscope. So it's very important to do that. Okay, so that will be my next video. I think I'm going to show you the diagram for, that would be diagram 7, how to use just one no-step transformer to make multiple parallel branches, and you can create very, very high amounts of voltage. But I'm going to be just using small voltages like 15 volts from this, I get from this 10-to-1 step-down transformer. So I'll be using small voltages first for safety to make sure it works. And if that does work, that is going to be really amazing what this voltage synthesis process can do. So I guess that wraps that up, and I'll see you on the next video. Thank you.